Hey, today we'll be solving the problem with track is frictionless except for a 10-meter stretch. The block is released from rest. Does the block collide with the spring, and if so, what will be the maximum compression of the spring? So in this case, we are given a block that's on top of the hill. It'll go down, and there's a friction surface. So what it's asking is will the block have enough velocity to get through the momentum? And if it does, what will be the maximum amount the spring will be compressed when it hits it? So in order to start it off, you want to set a kinetic energy equals to the compression of a spring plus the force of friction. Let me write it down for you. As shown by this equation, kinetic energy, for review, is 1/2 mass times velocity squared. The compression of the spring is 1/2 kx squared, and the force of friction is added on, which is the mu times the mass times gravity times distance. Now most of the values are given. All you need is the second velocity. So in this case, we are going to set kinetic energy, which is 1/2 mv squared, equal to potential energy, which is equal to mgh. And you plug in and basically the masses cancel out, which gives you 1/2 v squared equals gh multiplied by 2. V squared equals 2gh. You gotta get rid of the roots, which gives you the root of 2gh equals to v2. And that's going to be your formula to calculate the second velocity. Now gravity is given as 10, so you're going to plug it in. It's going to be square root of 2 times 10, and the height is already given as 5. So you're going to have a total of the square root of 100 for v2. Let me show you right there. And when that turns out, it turns into 10 meters per second. Now this is important because you need to plug it back into the original equation. So now that we have 10 meters per second, we could plug in all the numbers into the equation. So it's going to be 1/2 mass, which is 1 kilogram times 1 times 10 squared, which is what we just found, is equal to 1/2 k, which is the force given by the spring, and that's given us 200 times x squared sorry about that. I lost my word. Which is x squared, which is what we're solving for in this case, because that's the compression of the spring. Sorry, I lost my pen. Plus mu, which is 0.4, times the mass, which is 1, times gravity, which is given as 10, and the distance of the friction area, which is also given as 10 meters. And now that we have our equation, we could simply solve for it. It works out pretty easy. So 10 turns into 100. Divide that by 2 equals to 50 equals to, when you, half of 200 is 100, x squared plus 10 times 10 is 100 times 1, and then times 0.4, which makes it 40. Now subtract 40 on each side to get rid of it. 10 equals to 100 x squared, divide by 100 equals to over 10 equals to x squared, and you need to get rid of your root. And the square root of 1 over 10 meters is the maximum compression of the spring. So going back to the question, yes, the block will make it past the friction surface, and it will make it far enough to compress the spring, the square root of 1 over 10 meters.